In the previous week, we discussed a quantity called the momentum of a point particle. We started with this definition, P equal to mv for a point particle. We saw how the momentum of a point particle changes when force is applied on it according to Newton's law. And we carried this idea forward into systems of point particles and so on. In this week, our goal is to understand the concept of energy. We're going to define a number of quantities. Let's start by defining the kinetic energy of a point particle. And the kinetic energy of a point particle is defined as half mv square. Of course, since P equal to mv, it's not hard to show that the kinetic energy of a point particle of mass m moving at velocity v can also be written simply as p square by 2m. This is a kind of useful formula sometimes. What are the units of kinetic energy? Well, you can see that the SI units would be simply, well, m would have a unit of kilograms, and velocity square would be meter square per second square. So you have kg meter square per second square, or a shorthand way of writing that is just joules. Now there's an important point to be made here, that in defining a quantity like this, half mv square, it's clear that this is always a positive quantity. V square is the magnitude of the velocity vector, also called the speed. So the square of the speed. In other words, if you have a velocity vector of the particle given by vxi hat plus vyj hat plus vzk hat, the v square would simply be vx square plus vy square plus vz square. So kinetic energy is always positive. Let's look at an example. So suppose you have a ball of 200 grams thrown at an angle of 45 degrees above the horizontal at an initial speed of 5 meters per second. Let's find the change in kinetic energy between the initial point and the highest point on the trajectory. So of course you know that such a ball would, thrown initially at a speed of 5 meters per second, would follow a trajectory which is parabolic. It would reach a highest point and then crash back to the ground, right? So what's the initial kinetic energy? Well, that's very simple. The speed is 5 meters per second. Don't take components, you just need the magnitude of the velocity vector or the speed, and you would have half m v square is half into 0.2 into, well, 5 square, and that's just 25 into 0.1 or 2.5 joules. What about the kinetic energy at the highest point of the trajectory, which is here? Well, of course, at this point the velocity of the particle is not zero, right? It's still moving forward. The vertical component is 0. So the velocity vector at this point looks like this. Do we know something about its magnitude? Of course, this is a projectile, and as we know, the projectile only has a vertical acceleration. In other words, the vertical component of velocity changes, and as you see at the highest point, the vertical component of velocity is 0. The horizontal component of velocity does not change. Initially, the horizontal component of velocity was 5 cos 45. So at this point, it would also be 5 cos 45, and that gives you the speed of this particle at this point. You have v equal to 5 cos 45, so that KEF equal to half mvf square is just half into 0.2 into 5 square into half, because cos 45 is 1 by root 2. So you have 1.25 joules, and therefore the change in kinetic energy is 2.5 minus 1.25, which is 1.25 joules.